All right, let's try section 5.9, polynomial modeling. Hopefully you got the page number sorted out already. And let's take a look at this. First, I want to just put a note, something I said a minute ago. If you have n points, then you will have n minus 1. N minus 1, 1 less than n, is the maximum degree. Okay, so if you have 10 points, 9 is the maximum degree you can use for a polynomial model, and that holds true for however many points you have, however many pieces of data you have. But n minus 1 is perfect. I'm using a lot of quotes over here. Okay, I don't mean that it's perfect and that it will always be the best model, but it's perfect in that it will go through every single point that's there. So n minus 1 will fit it perfectly. n minus 1 is perfect, but maybe not the best. But maybe not the best. So n minus 1 is perfect, but maybe not the best. And we saw that when we had a large degree, it didn't necessarily fit it best. Okay, a couple calculated. We're going to get our TI-83s out here, so hopefully you already have one. If not, pause this and tell me to give you some calculators. But go ahead and do that. Clear them out so you get a fresh calculator. Just a couple things I want to remind ourselves of. The first thing, we have the Y1, which is a very powerful little shortcut that we're going to use to help us use our calculators. And to get there, it's vars, then over to Y vars, and then number 1 is function. And then you can select Y1 or Y2 or any of the Y's from there. And I think it's this is one of the best things in the TI-83, the great shortcut. And it's 3 menus deep to actually get there. So that's one of the little things I don't like about the 83s. But oh well, they're so good in other aspects. I'll continue to love them despite their downfalls. Let's see what else we have here. And to plot points, the other thing I want to remember how to do, to plot points, okay, you hit the Y equals key. You go up to plot 1, and you hit enter, and that will shade it in. Only do that once. If you hit enter on it again later on, it will turn it off. Leave it on. Leave it shaded, and we'll go through that in a second. And then you zoom stat. And that's the start. Usually after we zoom stat, we might zoom out a little bit to see what's going on. But to get started, we will zoom stat. Okay, just a couple little notes there. Let me see. Color this up a little bit. Woo! Okay, let's open up our books. I'm going to go to page 333 and look at problems number 2 and 3. So on page 333, numbers 2 and 3. And they're basically the continuation of the same problem. And it's about milk. It is about milk, and I'm going to do this in the calculator and take some notes as you see appropriate, I suppose. So stat, edit, and we need to put in those values, 55, 80, 105. So what they did is they took the data and they basically got rid of the 19. They subtracted away 1900, just took the last 2 digits. So 55, 80, 55, 80, and then 105, because I couldn't just put 05 here. It's later on. It's 25 years after that 80 data, so I need a 105 there. So we're basically subtracting 1,900 from those. And then L2, the actual value, let me see, 16.5, 16.5, 22.4, 22.4, and 22.9. Okay, and the first thing they say is they want us to put a line through these points. So let's go ahead. First, I want to actually see what these points look like. I'm going to plot the points, and to do that, I'm going to follow the instructions up there. Y1, go up to plot 1 and hit enter. And if I go down from there, you can see now it is now it's shaded in, it's selected, and then zoom stat. Where's zoom stat? Where? Oh, there it is, number 9. Zoom stat is number 9. So go ahead and select that, and there are my points. Okay. Now I'm going to look at first. I want to fit a line through those points. Okay, and I'm going to put the line under y1. I'm going to have the calculator actually type in the equation here. So stat calc linear regression. We've done this a number of times. So stat calc linear regression. And before we hit enter again, let's give the calculator some instructions. Say put this under y1. So to find that y1, remember up here we talked about it a second ago. Go to vars, vars and yvars, and y1. So this says, hey calculator, do your linear regression, but put it under y1. And let's hit enter. And we have those values there. That's lovely, but it's already done for us. They already put it under y1 for us. That's great. Makes it easy. Let's go ahead and graph this. Okay, and we can see the line there. It doesn't go through the points, but it gets kind of close to each of them, right? You can see it's kind of close. Let's do this with the quadratic as well. So stat calc, we're going to do a quadratic regression. Quadratic. Now I'm not going to put this under y1 because that would overwrite my line. So let's put it under y2. Vars, yvars, under y2. That way it doesn't erase what's in y1. So under y2. And then I'll hit enter that extra time. There we go. Beautiful. There's some values there for my quadratic regression. Hit the y equals. You can see it typed it in there for me. Great. X squared plus minus 1. Great. It's already in there. And let's go ahead and graph it. Okay, so there's my line. Looks great. And there's the quadratic regression. Now I have 3 points, and quadratic is degree 2, so it goes through all the points perfectly. It has to do that based on what we talked about a little bit ago. Okay, so even though it's perfect, is it best? Well, what I want to do is I want to change my viewing window a little bit. I want to zoom out so we can get a bigger picture. And I just selected zoom out, and now we can see a little bit more about what's going on. So remember the context of the problem. These are what? These are milk production values. Which one of these do you think more closely models milk production values? Okay, so is milk production going to come up like the quadratic and then go down to 0? Or is milk production going to increase steadily over time? What do you think is better? Well, of course, right, the quadratic, even though it goes through the points, milk production probably is not going to taper off and go to 0. This quadratic, it's an even degree and an odd leading coefficient. So it's down and down behavior. It's going to go down to infinity on both ends. Well, I don't think this is going to happen. I don't think the data would support something like that. I think that overall, I mean, they had maybe a great year this year and it went down a little bit there. But overall, I think this is going to just be increasing. I think the linear data is better. Okay, so I would probably say that the line is a better model, even though it's not of a greater degree. And the other thing it says, in problem 2, it says use the linear model, estimate production in 1995. Okay, well, I can do that. So let me see. I'm going to actually write that down. This was under number 2. This was got it 2. Okay, so got it number 2 says use linear, or use the line, use linear to estimate 1995. Okay, now this is going to be the value where x equals 95. Remember, we left off the 19 when we did our regressions. And I can actually, the linear is under y1, and I can use the calculator's y1 to give me that. Whoops. So let's just go back to the main screen, second and mode, that quit right there. Second and mode will bring it back to the main screen. That's quit. And I can tell the calculator, hey, calculator, look at y1 and plug in 95. And just like that, just like function notation, the calculator understands this. It says, okay, I'm going to put 95 into y1, and bam, 22.52. So at x equals 95, the line is at 22.52, and this means 22.52 billion gallons of milk. And how did I know that? I looked at the problem and it said that the y coordinates that we put in there were figures for billions of gallons of milk. So 22.52 billion gallons of milk in 1995. That is my estimate. Okay, it's not going to be exact, it's an estimate. I could also look on the graph. I could hit trace and make sure that you're on y1. Now we're on the list of points. I'm going to push down. Now I'm on y1. And I can type in 95, and it will bring me to that 22.52 right there as well. So a couple of different ways to do that. I think the screen is sometimes better. If you're using trace, it has to be a point that's on the screen. So if I wanted to put in 1,000, if I wanted to do trace and then 1,000, whoops, trace and then 1,000. Oh, okay, I need to get off. Okay, get off the points. I need to get back on the line. So if I hit 1,000 there, it's kind of embarrassing. It'll say invalid because it's not inside my window. If I go back to the main screen, and I just type 1,000, it will always just tell me the value. So sometimes using the main screen is a little bit easier. So what does this mean? This means 1,000 years. This is the year 2900. They're going to make that much milk. I think that's a little bit out of a range. And in fact, we call that extrapolation. When you pick a number that's really big, that's outside of the range of your data, that's not always going to necessarily be true. We can't really predict right now what's going to happen in the year, what was that be, 2900. That's kind of silly. So that's called extrapolation, and sometimes we don't do that. So that's those are your notes for section 5.9, polynomial modeling. Hopefully not anything too out of what we've already done. We've already talked about that a little bit.